Well, welcome to Google I/O 2016. It is so great to have you all with us here today. My name is Mike Procopio. I'm a software engineering manager on the Google Drive API team.
And my name is Randall Sarafa. I'm a product manager at WhatsApp. So what we're here to talk to you about today is a feature we built into WhatsApp for Android, which lets you back up and restore your messages from Google Drive. And we're here to tell you a little bit about how that went and how that came together and some of the challenges we had with that.
Okay. So kind of a high-level overview of where we're going here today. We'll take a look at messaging in general, right? And as well as the space where mobile devices are starting to proliferate significantly and usage has really hit an inflection point. Combined with cloud storage and Google Drive in general, we'll take a close look at how this works, including some technical details from both a product and engineering standpoint. Along the way, we did face several challenges. We'll look at some of those, what they were, both from the product and engineering standpoints as well. Taking a close look at the Drive API, and then followed by a live demo. So borrowing from Sundar's keynote yesterday, we truly are in the moment of mobile. Mobile is seeing massive adoption. Across the world, there are 3 billion connected users, and we are seeing over 50% of search queries coming from mobile. Some notes from Sundar's, the CEO of Google, Sundar's founder's letter from 2016. The mobile phone, more and more, is the remote control of our lives, and we're using these devices in ways that we didn't even think were possible as few as a few years ago. Just advance for me. So also from Sundar, think about it's not just messaging and communications, it's content generation, it's media generation. More and more, we're using these phones to take pictures. There was a tipping point when cameras started to show up on phones where the barrier to entry to actually taking a photo or 10 photos, which is much less than it used to be, right? So take a series of 10 photos. Sundar had noted that, and it's not hard to see how we arrive at this number, we could end up with 1 trillion photos taken across the world this year. That seems, when you start thinking about it, that's maybe 1 billion people taking 1,000 photos a year, if I'm doing my math right. So that's like 2 or 3 photos a day. That's not a lot. I take that many selfies in one day, so I'm clearly part of the problem here. Yeah, it's just a little slow.
Okay.
Yeah.
So when we think about messaging, what we're really thinking about is connecting people around the world, right? And the most fundamental way you can do that is by letting them text each other, and we've been doing that for years and years. But the messaging space has evolved. We now let people do much more than texting. We let them send photos and videos. We let them call each other over VoIP. And we let them do this on a wide variety of platforms, right? Obviously, with the goal of connecting people around the world, part of that goal means allowing everyone who has any kind of a phone really talk to one another. So what does this look like in the WhatsApp world? Well, how many people here, by the way, have ever used WhatsApp or are a WhatsApp user? Okay, great. So you are a very small fraction of our total user base. We've got over 1 billion people across the globe using WhatsApp. It's about 1 in 7 people on Earth using WhatsApp regularly. So pretty high number. We've got about 75% of those users on Android, and the rest of them are using one of our other supported platforms, which include iPhone, Windows Phone, and some older OSs like BlackBerry or some older Nokia platforms that we developed for. To give you an idea of how engaged those billion users are, they send a lot of messages. It's about 42 billion messages sent per day. So really, when we're thinking about WhatsApp, we're thinking about a product at scale. Of course, WhatsApp is more than just texting. It includes sending photos and videos, voice messages, location messages, contacts, and most recently, we let you now send documents on WhatsApp. So you can pick a document from your phone, you can pick one from Google Drive or another source. Pretty cool. Media actually represents a pretty significant portion of the messages that get sent per day. We've got 1.8 billion photos sent per day on WhatsApp, and we've got 250 million videos sent per day. So really high usage in terms of media. Nope. I'll do it.
There we are. Thanks. So complementing client devices and client applications like WhatsApp, we also have cloud storage. So data in the cloud is all about safely storing what's important to you. And an important part of this is the ability to access your data from wherever you're at. So increasingly, that means mobile devices. Once things are in the cloud, sharing and collaboration becomes easy and naturally expressed. In particular, sharing and collaboration around teams. And so more and more, we live in the cloud, and more, we're doing things via our mobile devices. Double click, there we are. So Google Drive is a cloud storage system that is focused on both enterprise and consumer users. It's a safe place for all of your files. It can store any type of file that you have, including some things that we may not usually associate as being file-like. So yes, photos, media, documents, spreadsheets, text files, CSVs, but also things like maps and sites and diagrams, things like that. Importantly, you can view it and increasingly interact with it. Not just view, but actually rich edit from anywhere across all sorts of client devices. Sharing with others is a key part of the value that Google Drive delivers. And then finally, as we'll see a little bit later, which is important to our integration, there is a large third-party app ecosystem with open and mature APIs. Double tap, come on. Thanks. So our joint mission then is to work together to preserve the memories of 1 billion users.
So why did we do this in the first place? Well, fundamentally, WhatsApp doesn't store your messages. And what I mean by that is WhatsApp doesn't store your messages on our servers. Really, your chat history lives on your device. So all the messages you're sending, the media you're sending, it's all stored on your device and not somewhere else. So given that that's the case, it's important that if you switch devices or you lose your phone or you upgrade phones, you have the ability to preserve all the chat history that you have. So we thought for our Android users, the best way to do that would be to use Google Drive. And there's 2 reasons for that. First, turns out most Android users have a Google account already signed into on their phone. So this means that a user can opt into this feature without having to create a new account of some kind or authenticate to another service. So it's really frictionless in that way. So we're really trying to build a simple mechanism for users. Second is Android devices have really good support for the Drive APIs, which means as a user who wants to back up your stuff to Google Drive, you don't need to install additional software, right? Most of the stuff lives in Google Play Services, so it's ready to go. As I mentioned before, we're really talking about integration at scale, which Mike is going to talk a lot about a little bit later. Now, in terms of how this actually works in the product, we want to walk you through some of the challenges we had and also some of the decisions we made in terms of how to design this user experience. Let's see. So our backups are opt-in. What this means is that we need a user to actually turn on Google Drive backups. And we obviously want a way to do this that is really obvious to the user, right? We want them to know the feature actually exists in the first place. So we designed a full screen activity that prompts users to opt into Google Drive backups. And we present them with this activity on a time interval. It's about once every few months. It's a little, we ask them kind of up front when they're using the app, and we back off to once every few months. By the way, the reason we do a time-based approach as opposed to saying, hey, maybe we'll ask a user when they update the app is because we update our app frequently, right? So that gets annoying. So you don't want this to become noise. You want it to be meaningful to the user. First thing we ask them is to select a backup frequency, daily, weekly, or monthly. And the reason we actually do this is while our backups are incremental, there's one part of the backup, it's a small part of the backup, that actually gets backed up fresh every single time a backup is done. So by dialing back the backup frequency, choosing a less frequent backup cycle, you can actually save some data, some bandwidth. And importantly, a lot of WhatsApp users are very conscious of the data usage that they're using because data around the world is much more expensive. Right? So we're trying to build controls for our users that allow them to really say how much data they want to use and be able to preserve that if necessary. We ask them to connect a Google account. Most Android users have just one on their phone, so we automatically choose that one. When they connect the Google account, you just get presented with a system-level prompt asking you to connect Google Drive to WhatsApp. It's a permission prompt. And the last thing we let users do is decide whether they want to back up videos or not. The reason we do this is because videos actually represent a pretty large portion of the overall backup size, or they can. So on average, between a user who backups videos and one who chooses not to do it, there's about a 300 megabyte saving on average. So you can really, if you don't have much Google Drive storage or you don't really want to expend the bandwidth to back that up, you can choose to not include the video if you want. Okay, so I opt into backups. I got my stuff backed up. Now, how do you actually get that data, right? So I switch phones, or my phone, drops in a toilet, something like that. I get a new phone. How do you actually get all your chats back? Well, we basically ask you to do this at registration time, right? You install WhatsApp, tell us what your phone number is, and then we look for a backup. When we find a backup and the user decides to restore it, the restore happens in 2 stages. First, we restore your chats. And what I mean by that is really just the chat database, which is kind of mostly just text messages. Doesn't include any media. So that's a smaller portion of the backup, right? And we do this synchronously, so we don't let the user into the app until this finishes. There's a reason for that. When the user actually ends up in the app, we want them to see all their chats right away, right? Otherwise, they're gonna think something might have gone wrong, we lost some of their data or something like that. So we restore the chat database synchronously. However, with media, because that represents such a large portion of the overall backup size, we do that asynchronously. So we let you into the app, and if you look at the bottom screenshot here, we basically restore the media in the background, and we kind of tell you that at the top of your chat list. This means the user doesn't have to sit around waiting for a huge backup to restore, potentially, right? And if they have slow network or they're doing this over cellular for some reason, that way they're in the app ready to go and their media will restore. We actually restore your most recent media first, right? Which makes sense because you're most likely to see that in your chat history. And we're always monitoring network conditions, right? So we pause the restore if you drop off Wi-Fi or if your battery gets low or things like that. I'll make one comment about the UI here. We actually designed some animations in the restore process. And the reason we thought this was actually important was so that the user has an extra indication that progress is happening, right? So the dots animate in the top screenshot, or those 2 arrows animate in the bottom screenshot, letting the user know something's going on. When the restore is paused or something's not happening, we actually stop those animations. So just reinforce in the UI to the user what's actually going on. And from there, you get your chats back and you're ready to go.
Thanks. Okay, so we've had a pretty clear look from on the product side for how this works, both in terms of backup and restore flows, which are the 2 main flows in this integration. Let's back up a little bit and from a higher level view and check out the architectural overview for how the overall system works. There we are. So, like all good architecture diagrams, first off, these colors I spent a lot of time on, so I hope that they work. All good architecture diagrams start with the storage services on the bottom, and kind of the clients at the top, and that's what we have here, right? So notice the Drive clients and the WhatsApp client on the top. The very bottom, you have both WhatsApp and Google Drive backend server technologies. So on Drive side, and we'll see this a few times in this integration, there's 2 key services involved in managing files, right? There's the service that handles binary file content, so the actual content of the file, and then all of the metadata, which is stored separately and optimized differently because it's a different kind of use case. So things like title and MIME type. Of course, there's a business logic on top of that and a good caching layer, probably many caching layers, the solution to all known computer science problems, and quite a few bugs, actually, cause quite a few bugs. One of the key things about this slide that influences our integration is this unified first-party and third-party Drive API. That's the section in the middle, and that's the team that I'm fortunate to work on. And what this is the programmatic entry point into Drive, traditional API. One of the key takeaways of this is that the same set of APIs, the exact same endpoints, and the exact same server infrastructure serves both first-party Drive clients like Drive on the web, Mac, PC, Android, iOS, Chrome OS, and the entire third-party ecosystem, including WhatsApp. So what this means is there's anything you can do with a first-party app, you can do with a third-party app, minus a few specific exceptions around security. And so according to the diagram, WhatsApp client has their lightweight wrapper around Drive APIs. They're calling the exact same set of endpoints that we do. So when the user opts into backup, files will become uploaded via the entry points in the Drive API, go through several layers of caching, and then finally end up in our storage servers. Restore is the similar path on the way back out. Thank you. Let's take a look specifically at what a backup flow looks like, because this is a pretty brilliant engineering piece on behalf of the WhatsApp team, WhatsApp product and engineering team. So at the end of the day, we're making API calls against the Drive API. That's the methods that you see here on the left. Traditional create, read, update, delete, CRUD, RESTful API sorts of methods. These should probably these may look familiar. So first, we're going to look for backups. That's what this list is about, right? We're actually querying by title. We're looking for both the main folder that indicates a backup is present, as well as the media folder. every backup has a file map which contains links to, it contains a list of the IDs of the files stored in Drive that match the media on the device. So we're basically looking for that. Once we find it, we read it in, and then we begin the backup. And what this means is doing a differential comparison between what's on the device and what was on the existing file map. So it's basically a diff, because one of the important things is we don't want to re-upload things we've already uploaded. Bandwidth conservation is critical for this use case. Finally, so we'll start uploading media items, we'll upload the message database, and we'll upload the new file map. And then something very important happens. This fourth line from the bottom, this properties insert call. Up to this point, the network connection could fail, the phone could disappear, and the user's backup would still be intact. This is a really sound, defense-in-depth, robust engineering on behalf of the WhatsApp client, because it means that only when we finally make this switch to the new file map, updating a pointer basically, do we actually, is the new backup in place. Finally, we'll do some cleanup and deleting the old files. Any items that are not on the device that were in Drive are also cleaned up. Restore flow is comparatively simple. Reads tend to be a little easier than writes. We look for a backup. If a backup is present, we can prompt the user, as we'll see in our demo. We'll get the contents of the file map to actually find the IDs, and then we'll begin background restoration of the user's media in the background, and then at that point, the user can begin using WhatsApp right away. Some quick technical details. I have a slide here. Randall has one as well. As far as HTTP libraries, we use HTTP URL connection on most modern devices. This integration, Drive Backup, is supported fairly on I think, Gingerbread. But for older devices, we will use the Apache HTTP library. Authentication is typically a very tricky area, but on Android, fundamentally what it comes down to is using OAuth 2, where you can get a token, which is available built-in Android APIs, and then finally you have to pass that token in a RESTful API call as part of a header. And then finally, rate limiting is important both in terms of client and server. Things can fail on the server, transient errors, that kind of a thing. So the client has robust retry with exponential backoff implemented.
A few other technical details. So we actually use the HTTP API for Google Drive rather than the Drive Java SDK. The reason we do this is the SDK is kind of big, and that was pushing us up against our 64K method limit, so we decided to go with the HTTP API. It's also a little bit more flexible in terms of how we could design some of the calls that we were making. I also want to mention the backup window, right? When do we actually back up? And we do this to optimize. We choose a backup window that optimizes for whether the person's phone is going to be charged and connected to Wi-Fi. So we think usually that this happens at night, right? When you're sleeping. So you charge your phone at night. If you're at home, you probably have Wi-Fi. So we kind of optimize for that condition. So we basically say we pick a 4-hour window. Something, I think it's like 2 and 6 a.m., between 2 and 6 a.m. And we basically, for a given user, randomize when they'll back up. The reason we choose a random time for the user to back up is so that we don't really bring down Google servers by having a bunch of people, wake up at 2 a.m., have their phones wake up at 2 a.m., kick a backup off, right? This would be pretty bad. So we kind of choose a random window. That helps us really get where we want. And of course, we're always looking for network conditions, battery, et cetera, right? So we won't kick a backup off if your phone's battery is low. We won't kick one off if you're not in the right network condition. But once you are in those proper conditions, we'll just start the backup, right? So if I am asleep at night, my phone is dead, by the time I get to work in the morning and plug my phone into the charger, we'll just kick the backup off for that day at that time. So we're kind of flexible, actually, in that way. So where are we at today? So we fully rolled the feature out in January of this year. Took several months to actually roll it out completely, and we're going to talk about the rollout process a little bit later. As I mentioned before, we've got over 1 billion people on WhatsApp, 75% of them are on Android, and of our Android users, we have about 40% of them opted into Google Drive backups today. So pretty good numbers. That will likely continue to increase over time as people get prompted, as I mentioned, once every few months.
Good. Well, I know we make it look easy, but the truth is there were a lot of challenges along the way, and we're going to take kind of a very transparent behind-the-scenes look at what some of these were. Thanks, Randall. So first and foremost, with an integration like WhatsApp, we think scale. how can we accommodate an integration this size with 1 billion users with daily backups, backing up new content as it's generated? How do we absorb the initial backup data that's on the user device when they're opted in, right? Because that's a large kind of initial upload, and then once that's finished, it's more of a natural thing. Multiplied by 1 billion users, and things start to times an opt-in rate, and things start to get very interesting quickly. Large scale can mean a lot of different things. Users, and we're talking 1 billion times the opt-in rate, that's measured in hundreds of millions of users. Drive API, queries per second. If you have that many users backing up at night, you're talking queries into the hundreds of thousands of uploads per second, which is pretty intense for any service. That takes a lot. It requires a lot of instances of Drive server backends. At the end of the day, Drive and the API and all the backends, it is a server. We're listening for requests on a socket. And any given JVM, any given task or instance can only handle so many. And so what do? We just start spinning up lots of these instances to kind of handle all the requests as they come in. And load balancing and kind of comes into play there. Also, not just in terms of the server production engineering, but the storage capacity matters. Both in terms of size of the item stored, which matters when we're writing file content to the binary kind of service, as well as raw number of items. So for all of these reasons, this is a super large scale integration that takes a lot of very careful planning. In particular, when we talk about capacity planning, we're talking about provisioning. And the conversation went a little bit like this. Somebody heard that we were working on a WhatsApp thing, as they called it, and they asked me how big it was. It was like, pretty big. And so at Google, we think pretty big. They're like, oh, it's like a Gmail. We can handle that. It's like, no, it might be bigger. And at that point, people start to get a little nervous, because if you don't properly provision, you're going to truly take down and overwhelm active servers that are trying to fulfill requests from other people. So provisioning and estimation is critical, especially for an integration of this size. So we need to estimate it. Well, how can we do that? Two general approaches, just to kind of give a quick overview of how we do this in practice. You can model it, right? You can model it from first principles. So you have a theoretical way to do estimates. Total of number of users times opt-in rate, number of files that every person has, number of files that each user generates over time on a daily basis. Different types require different resources. For example, videos get transcoded into multiple formats for playback on different platforms, so they'll impact us in different ways. So that's your model, and like all good models, there's some saying about this. They're useful to varying degree. What we find to be a little more reliable in this case is empirical observation. So we do a trial rollout with WhatsApp's beta users. They have an excellent beta program, and then we say that's a portion of the overall user base. Let's multiply it by that scalar factor. In our case, these two roughly agreed, and so that gave us good confidence that this is these are the resources that we need to provision.
So I want to talk a little bit about bandwidth reduction. As I mentioned, WhatsApp users, we have users all around the world, right? And so we're really interested in making sure that we're using only the amount of data that we need to use, making sure that's efficient, and trying to speed things up, right? Trying to make backups quick, restores quick. So one of the primary ways we do this is backups are incremental, right, for the most part. So this means that if I backed up a photo one day, I don't need to go and back that up the next time I go ahead and kick off a backup. Makes sense. One of the other ways we do this is we actually have byte-level resumes for uploads and downloads of every file. So if I'm uploading a photo and the connection drops and for some reason I don't finish it, I can actually just resume at the byte level that upload, right? Really efficient to do that. So this especially comes in handy with larger media files. If you think about a video that might be 16 megabytes, this type of thing actually comes in handy. We also optimize a lot of our API calls. So we do batch deletes for removed files, right? So a user goes and deletes a bunch of photos from a WhatsApp chat. The next day when we do the backup, we're going to need to delete those files out of Google Drive, so we batch those up and do it. And when we're fetching files at the time of restore, we actually fetch the metadata for those files simultaneously, right? So we don't have to make sequential API calls in order to actually do that. The last thing I'll say is when we're actually fetching the metadata for files, we only look at the fields that we really need. There are, I think, dozens and dozens of them, and we actually only look at about a handful, right? So we're actually optimizing how we're actually reading the metadata so that we can, again, optimize the API call for efficiency.
All right. Another challenge is it has to be fast and it has to work. We call that performance and reliability. We have a saying, fast is our favorite feature. Speed matters. We are a service, right? We are designed to fulfill requests from all sorts of applications, often where a user is waiting. Speed actually counts. For backup, it's a little bit different. It's unattended, so typically between the hours of 2 and 6 a.m. in a backup window, sequential upload is okay. Speed is not as critical, but at the same time, we do want to be fast. Because while if we're slow, the device is still on, we're using Wi-Fi, we're using connectivity, that translates to battery. So we want to be as lean as possible, even on the server, even for an unattended use case. Restore is attended, the user is waiting. As you'll see in the demo, we're restoring our items, they're in the background, maybe the user is waiting for that content to be restored. So it's important to be fast. One way we can get around this is to parallelize downloads. It turns out that pulling bytes from concurrent streams works pretty well, scales well, and doesn't chew up any more CPU than you would expect from linear, and you get the expected, almost theoretically optimal speed up in terms of user perceived latency. So fast is great, but if it doesn't work at all, then basically it took an infinite amount of time, right? So we have to actually answer the request. Reliability is important. This is hard for backup. This is hard for writes, right? Because you're writing to multiple systems, you're dealing with 4 or 5 megabyte files, you're buffering things, you're chunking, you're opening up upload sessions, you're finalizing them, you're writing the metadata once that's done, you're doing post-processing. We have to do this super reliably. What does reliable mean? Well, I mean, that's a varying degree, but in general, if you are talking about, for example, only 1 in 100,000 or 1 in a million requests failing in that kind of range, that's pretty good, because for the requests that do fail, a simple retry will likely clear it up, and users will generally have no idea. So 4 nines, for example, is a kind of a reasonable target, and it's quite a feat when you're talking about writing data at that scale.
So despite all our best efforts for reliability, things actually do go wrong. And this is actually, handling errors is actually both an engineering challenge as well as a user experience challenge. Here's why. When something goes wrong, you don't want to constantly tell the user that something is wrong, right? Otherwise, they start to think your service is reliable. This is especially true for things that happen where we can recover gracefully from them. So I'll give you an example. Let's say the user's phone isn't on in the backup window, right? So their phone is off at night. We realize we can't perform a backup at 2 a.m. We'll just wait and defer the backup until later in the day when the proper conditions are met. Same is true for network. Sometimes we get miscellaneous server errors, right? Like error 500, that we don't really know exactly what's going on. So we just kind of wait. We try the backup again. If it works, it works. If it doesn't, we're still kind of silent about it. And I'll tell you when we're not. So we have a class of errors where so that's a class of errors that sort of we can recover silently from, but we've also got this class of errors that require user action in order to recover from. So a great example of this is authentication. Let's say you go and change your Google password, right? And you forget to update it on your Android device. Well, at this point, we can't actually authenticate into Google Drive in order to back up. So we actually tell the user immediately for that type of an error to go resolve this issue, because we know that no matter how many times we're going to try this backup, it's never going to work unless the user does something about it. Another type of error that happens in this category is storage issues, right? Let's say you run out of Google Drive quota, or your phone runs out of storage, those types of things. Again, we tell the user explicitly, please go fix this thing. So for the errors that we think we can recover gracefully from, what we do is we keep trying, and we don't tell the user this backup hasn't occurred for several days, right? So say I have daily backup set. One day the backup doesn't work. We just kind of wait. We try it the next day. If it works, it works. Great. If by I think like the 4th or 5th day at that point, we'll tell the user something maybe is not going on. But really, we're trying to just do this gracefully. The balance we're really trying to strike, of course, is you don't want to annoy the user into thinking this thing isn't working, but also you want the user to actually be able to back their stuff up, because even losing 1, 2, 3, 4 days of messages can be pretty painful sometimes, right? Hurts to lose that data. Okay, let's talk a little bit about rollout. And we're going to cover this in detail. So how did we roll this out? Well, we distribute WhatsApp in 2 ways. We've got an APK download that we distribute on our website. and we also distribute it through the Play Store. Obviously, a vast majority of our users get it from the Play Store. What this means, however, is that you can actually test things, test updates with the website population so that because the population is small, and you can kind of actually use that almost like a beta testing pool. So we started there, and we did this as a percentage rollout. So we said, hey, we'll roll this out to 5% of our website users, and then ramp that up. And then we did a percentage rollout for our Play Store users. Percentage rollout's really important, obviously, because we don't want to just turn this on all at once. We want to find the bugs that we have in the client. We want to make sure the servers can handle it, all those types of things, right? So we monitor this very closely, because again, we're dealing with user data. This stuff is precious. You don't want to screw it up. Of course, even when you're doing a percentage rollout, one thing to keep in mind is that there is a natural user upgrade cycle, right? So say we ship, a version of WhatsApp with Google Drive in it. We enable it for 5% of users. Not everyone's on that build yet, so they're going to upgrade over time. So actually, in absolute numbers, the 5% grows, right? So keep that in mind. It's another interesting thing that we had to deal with. Towards the end of the rollout cycle, we shifted from a percentage rollout to a regional rollout. Mike's going to tell you why we did that in a little bit. And of course, just some critical things that we did. Client monitoring was really important. So we were constantly monitoring success rates for backups and restores. We were constantly monitoring, if a backup was failing, what type of error were we seeing, and this let us find bugs and make optimizations along the way to make all of this more reliable. On Mike's side, they were obviously doing a lot of server monitoring to make sure we didn't bring down Google servers, which we mostly didn't. And communication's key, right? So actually our teams communicated frequently. Every time there was a client change that we thought would affect the way the server would respond, we communicated that, and we still do that today. So communication, really good when you're dealing with this type of thing.
Okay, so let's take a look at what the rollout actually looked like, and we'll speed things up here a little bit. This is an actual graph of queries to the Drive API from WhatsApp. So you can kind of see on the left, we had our preview rollout where we're kind of testing things out to see how things are scaling. Everything was working great. From that, we're able to understand how much provisioning we need. So there's kind of a quiet period while we allocate the resources, plan the rollout, and then we start gradually bumping things up. A couple of percent, 3% at a time. We wait for that, and we see how things behaved. And at some point, we were ready to do daily rollouts. And that's a section in the middle. Not a whole lot of sleeping right now. During this phase, 3% a day until it was basically done. There was an interesting point that we'll talk about here where we had to pause the rollout for some regions. We'll take a look why. And then after the new year, we resumed it. And then towards the end, we kind of have this natural linear-esque growth at full rollout. Next slide. So one quick look for one of the more interesting things that happened in the rollout. So data centers and services, there are lots of data centers around the world. They are not uniformly distributed. And what that means is that you have kind of local data centers where file uploads will go, but also at Google and many places, not all servers or services will run in every data center. Seems like it's fine, and you just bounce the traffic back and forth, but it turns out to be interesting in the following scenario. So broadly speaking here, we have data centers on various continents. There's a data center that accepts upload kind of on the west of the Pacific, and there's a data center east of the Pacific that Drive runs in particular the metadata storage layer. What was happening was we were uploading the data to the local data center. That was great, super low latency, it was good. Post-processing around checksums had to be done in Drive because checksums are part of the metadata. To do that, we needed to do calculated checksum. You need the file content. Drive did not run in the local data center that the file upload service ran in. So what was happening was Drive was pulling all of the bytes across the Pacific from that data center. I mean, ultimately, we're shipping bytes in a pipe right across an ocean. That pipe is very, very much limited. It's expensive to use. And if you saturate it, things like YouTube could start to be impacted. So we had to pause our rollout for the regions that were impacted. And here is what we did. The solution to this was we paused the rollout. We moved the post-processing in Drive, in particular the checksumming, into the same data centers associated with the regional uploads, right? So then all the post-processing was done. We didn't have to transfer, petabytes upon petabytes back and forth, and everybody was happy. We were able to gradually resume the rollout. that was a very interesting kind of scenario. Quick look at the API and ecosystem, and I think we're doing pretty well here on time. We'll have time for a demo here. So the Drive API has been around for almost 10 years now, and next slide for me, please. And it very powerful and expressive. It can do a lot of things that you would expect around file management, uploads and downloads, of course, applicable to our use case, revisions, listening for changes on a file or a folder or drive wide, full programmatic management of sharing and permissions, applicable to this integration, the use of custom third-party properties, push notifications, and as we noted before, the first-party Drive clients, so Drive on web and Android, iOS, everything, all use the same set of APIs. So, we have a rich third-party ecosystem because we've had open APIs since 2008. This is part of our platform. This is not an afterthought. Embracing the developer community is part of our MO, our DNA, our vision. It is something that we are paying very much a lot of close attention to. So apps that do everything imaginable have popped up in the past almost decade. Faxing, editing, rendering, syncing and backup, data protection, data validation, data integrity, enterprise use cases, document workflows, games, music players, anything you can think of has probably been done in this ecosystem. So this is an example of what some of the apps look like right now in the Chrome Web Store. The variety of apps is reflective of increasing number of Android apps embracing Drive APIs for varying degrees, including storage and backup like the WhatsApp use case. All right, here is a graph of Drive API growth. And one of the key things to take away here is that we want to embrace a third-party community. And what that means is we understand that scale is important. We know how to scale, and we understand that your apps need to scale as well. So whatever quota you need, we are able to grant. We are watching this very carefully, and we're provisioning along the way. And you can see we have a nice kind of linear growth that we're planning for on an ongoing basis. And as long as it continues roughly linearly, people are generally happy here. So this looks great. Last 300 days on that. All right, demo time.
You want to do it?
Yeah, I think we have a perfect amount of time here. So we wanted to demo the end-to-end flow. What could possibly go wrong, as we like to say. We can switch over here. So what we'll do is Randall and I have a conversation going, if that's showing up there. Yep. We're going to take a selfie, we're going to back it up, we're going to clear the data on the device, and then attempt a restore using Google I/O Wi-Fi because we like to live dangerously. Okay, bud, here we go.
50-50 shot.
Exactly. All right, what are we doing? What are we?
Yeah,
smiling, restriking a pose. Here, let's smile. Okay. Excellent. All right. Yo. Maybe just an emoji there, just for good measure. All right. So there it is, showing up there. Looks good. Cool. All right. So to trigger manual backup, thanks. Yeah, user can back up at any time. To trigger, I have mine set up to update backup every night, chats and chat backup. We can also back up manually. So first, we create a local backup. We're going to query Drive to figure out what things are there, what things are on the device, and do that kind of differential computation. We figure it out. We upload the new photo. That's happening fairly quickly, which is great. When that's done, remember as we saw before, we update the pointer to the new file map, which basically says this backup is live and ready to go. That's what's happening now. It's done in and out in 15 or 20 seconds.
So that's also the incremental backup happening right there, right? Mm-hmm. So you see how quick it's actually going.
Right.
So just a minor amount of data has changed in between.
So let's go ahead and clear things off of the device. So first off, what we can do, and I'll show you like the coolest little. There we are. Yep. So that'll get us into storage. Clear off the data and the cache from the local device. And then importantly, we also need to go into the actual built-in storage manager here on Android, which is a neat little thing that I found under storage and USB. You scroll down, there's this cool little thing, Explore here. This is an actual built-in Android file manager. So we can go to WhatsApp. WhatsApp stores this media on the SD card, and I can actually go ahead and clear that.
Basically what we're doing is we're simulating what would happen if someone got a new phone, right? Like they're not going to really have any data on their phone yet. They're not going to have WhatsApp installed, so all these things don't really exist. right? So
All right.
what happens in the world when you get a new phone? So you install WhatsApp, you're back at registration, we're gonna ask you for your phone number first.
So we are officially now in a kind of a zero state, cleared off everything. As Randall said, we'll uninstall it. And then I actually have a local version of it right here under downloads. WhatsApp APK, so we'll install it locally again, and that should trigger the restore flow once it installs. So what that'll do is opting in, the user will be prompted to be able to restore their items when it's ready. This happens after account setup and verification, which is based on your phone number. And then the key thing to note about restore is that although all the media is actually restored in the background. Anything else you want to say about this flow?
No, so we'll show you right now is where we do this as part of the process. One thing to keep in mind when we look for backups and registration, it kind of requires the Google account being on the device. So we have some logic for letting a user know, like, hey, maybe you don't have a Google account on your phone. If you backed up previously, why don't you go ahead and sign in so you can actually restore it. We also only give you one opportunity to restore. That's at install time. The reason is because it creates a lot of complexity to do it later in terms of how you merge chat databases and do all those types of things. So we just kind of give you the opportunity up front, restore it. It's just much more reliable to do it that way.
All right. I set up my account. It was automatically verified via SMS. You can see the notification there. And then here, as Randall just noted, we looked for a backup and we found a backup. We have the opportunity to restore it from the cloud.
So importantly, we're also showing the user the size of this. We say, like, this is how much we're actually going to download. So when Mike actually hits restore, what we're doing is what I mentioned before. We're restoring the chat database first. We do this synchronously. So these are your messages. We let you know, hey, 6,000 of them are restored. And we actually tell the user your media will be restored in the background. So when Mike actually comes into WhatsApp, you're going to see something at the top of the chat list that says restoring media. And that's going to kick off getting all your photos, your videos, et cetera, which again are the biggest part of a user's backup typically. You can see that right there. As I mentioned before, we restored the most recent media first. So if you actually go into our chat, you'll probably see the photo that Mike sent already restored, right? So we optimize for recent messages, which obviously makes sense. You want to see that stuff up front. And that's our demo.
Cool. Thank you, everyone, for your attention, for being here today. We really appreciated having the chance to kind of give you a behind-the-scenes look here.